Hello my dear students, my name is Benathan Patton and I welcome you to the channel Classroom where we learn together. So today we will be starting the numericals. So for most of you the numericals are a headache, isn't it? But do not worry, okay? I'm here to teach you and I'll teach you in the simplest and the most easiest way to understand. So all you have to do is grab your notebook, a pen or a pencil and follow. So we will do together and I assure you, okay, I give you my assurance that you will understand. So step by step I'll explain to you, making sure that I do not hurry, okay, but you understand along the way. So let's start the first question together. Okay, this is from your exercise. Okay, this is the first question, question number 1, which actually is an MCQ. So there are 4 options given to you, but then without knowing the answer you cannot pick the correct answer, isn't it? So we have to solve. Okay, we do not memorize. We will not memorize and go, because in exam the same question will not come. So memorizing is useless. Okay, you're just wasting your time. So in the exam you go and write, but then the question that you have memorized did not come. So you did study, but then the question did not come, so all your studying has gone to waste. So let's not do that. Okay, let's not memorize stuffs, let's understand stuffs, especially maths and science. Okay, so let's solve the question together and learn together. So the first thing to solve a numerical is to study the question thoroughly, once, twice, thrice. Keep studying until unless you get something out of the question. So let's read the question. The question reads, a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R bar, then the ratio R by R dash is. Now this is called R dash, okay, or R bar. Remember, so like this. Now this is called bar. Okay, these are called bar or dash. My alarm bell is ringing. So we have read the question. On reading the question, what we know is that there is a piece of wire whose resistance is R, and this piece of wire is cut into 5 equal parts. So let us draw the long wire, and then this long wire has got resistance R, and this long wire is cut into 5 equal parts. So let's break this into 5 equal parts. So let's say part 1, part 2, part 3, part 4, part 5, like that. Since they are broken into 5 equal parts, let me draw them here. 1, 2, 3, 4, and 5. So these are the 5 parts which are broken from this long piece of wire. I hope you are following till now. Alright. Now, what is happening? The resistance of the wire is R. The overall resistance is R. When the wire is in its full form, the resistance is R. But the wire is broken down into 5 equal parts. So even the resistance will be divided into 5 equal parts. So the new resistance of these wires will be, it will be R divided by 5. So the new resistance of this wire will be R divided by 5. R divided by 5, R divided by 5, R divided by 5, R divided by 5. Alright, see, if you do not understand this, let me give you a side example. So suppose the length of this wire is 50. The total length of this wire is 50. So total length is 50. Okay. Then this wire is broken down into 5 equal parts. So the length of each part, the length of each new part will be how much? What will be the new length of this each new part? The length of this new part will be, so there are 5 of them. So what will be the length of this new part? The length will be 50 divided by 5, which is 10. So each part is 10, 10, 10, 10, 10. 10 plus 10 plus 10 will give you 50 or not? Yes, there you go. So if you understand this, bring the same understanding to this question. This was discussed in terms of length. Now here we are discussing in terms of resistance. But remember, the wires are broken into 5 equal parts. So whatever value of R it is, it will get broken into 5 equal parts. So just like 50 divided by 5, 50 is your length, is not? So 50 divided by 5, I'm doing the same thing. R divided by 5, R divided by 5, R divided by 5, R divided by 5, R divided by 5. Followed? Alright. So like I said, if you do not understand directly, we'll have to go to other ways and learn and come back here. Understood? So a piece of wire of resistance R is cut into 5 equal parts. Done. Okay, so we have cut it into 5 equal parts, and the resistance has also been divided into 5 equal parts. Next question, these parts are then connected in parallel. Now these are connected in parallel, so we'll have to join them in parallel. So parallel, 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 parallel. So let's join them in parallel. That's it. This is how the new figure will look like. Okay, are connected in parallel. If the equivalent resistance of this combination is R dash. Now remember, we have already discussed a formula on resistances in series and resistances in parallel. For resistances in parallel, the formula is 1 by Rp is equal to 1 by R1 plus 1 by R2. It goes on, is it not? So this is called the equivalent resistance. Okay, this is called the equivalent resistance. So this is given to us. This, as per the question, will be R bar. So this will be R bar. This is the question telling us. And then we have to find the ratio of R, which is this one, divided by R bar. Alright, so now we have read the question and we will solve. So the first thing you will write is given. So what is given to us? We will write whatever information we get from the question. So what we know is that we have a wire having resistance R. So given resistance of long wire is R. Okay, then the long wire gets divided into 5 equal parts. So we can write new resistance after division. What is the new resistance after division? They are R by 5 only. Okay, each of them are R by 5. We are describing about this one. Now what we will do, we will try to find the equivalent resistance using this formula. Okay, so we will write, we always declare, okay, before we directly go. So we will declare that since the combination is in parallel, we'll be using this formula. Always declare, since combination is in parallel, we have what do we have? Formula 1 by Rp is equal to 1 by R1 plus 1 by R2. Now how many R should I go? I should go till R5 because this is R1, R2, R3, R4, R5. So plus R3 plus R4 plus R5. Now Rp, like the question has told us, it will be R bar. So instead of Rp, I'll write R bar. And R1 value, R2 value, R3 value, R4 value, R5 value, they are all R by 5. Now here, this is the part which most of the students, they get confused like anything, because double fraction is here. So we have 1 by, see, what are we going to get? 1 by, R1 value is R by 5. See, this is the double fraction, is not? Most of you are comfortable solving these kind of questions. This is the simple fraction and this is the double fraction. Many students, they find this difficult and they give up. You should not give up, okay? I'll teach you a simple technique which is taught to class 4-5 students how to deal with double fraction, and then you tell me, okay, whether you should give up or not. So let me show you. So how do we do this? So what you are going to do, this one, see, let me erase this one now. So you have 1 by R1. Now this is the main division. Okay, whenever we are dealing with double fraction, remember the main division which comes from the formula. I repeat, remember the main division, which means we are talking about this one, which comes from the formula. Okay, not the value. This division which you are getting, R by 5, this comes from the value. We are not talking about this division. We are talking about the main division which comes from the formula, which means this one. So always write the main division longer and then the value one smaller. Okay, at least so that your eyes can know now which is the main division, which is the value division. Okay, then what you do next is the main division you convert it into the symbolic division. So I'm telling you to do like this. Okay, this is the symbolic division, and write down this one as it is. Next, what will happen? We convert this symbolic division. Okay, I'm saying symbolic because division का symbol तो ये है ना. Convert the symbolic division into multiplication. So this will convert into multiplication. When the division gets converted into multiplication, denominator goes up, numerator goes down. Don't forget that. And so the answer is 5 by R. So you get like this. So you're gonna get 5 by R. This, okay, for those of you who already know this, okay, those who are quite well in mathematics, you know, from here you will directly get this. So they will omit these two steps. Okay, they'll get this one and they will omit these two steps, and from this step they'll directly get this one, which I want all of you to do that. Okay, so but if you have doubts, follow this long step where there will be 2 extra steps. Okay, you're not going to lose mark for this, so do it. Okay, do it and do this and learn. Okay, don't worry, just do it. So now that I've shown you that how the values are going to be, we'll use this technique. So 1 by, at least let us put the values 1 by, we have R by 5, 1 by R by 5, the main one. Okay, don't make mistake, make it longer. You are the one writing, so train your mind, train your brain also. 1 2 3 4 5. Okay, you are the one doing it, so you have to train your mind, train your brain. Okay, it is your responsibility to train your brain. R bar is equal to, so we know what we're going to get. We're going to get 5 by R. Okay, like this. Okay, once you become an expert, just you know that this will be the answer, so just chill and write like this. Okay, then what we do is we take LCM. So 1 by LCM will give you R, and here you're getting so 5 plus 5 plus 5 plus 5. What will we get? Now let me erase this. Okay, I'm running out of space. So from this we go to this one. So 1 by R dash is equal to, you get 25 by R, copper cross multiplication. This is the value of R dash. So now the question wants us to find the ratio of R by R dash. So the question wants us to find the ratio of R by R dash. They want us to find the ratio of R by R dash. So R by R dash, R value is this one, R value is this only. Okay, and then this one, the one which is from the formula. Okay, make it longer, and R dash value is this one. So R dash value is this one. Okay, then again R by R dash, it will be, well, you know now what will happen here. Okay, you already know what will happen here. So it will be R into 25 by R. So R gets cancelled. So the answer for R by R dash is 25 by 1, which is 25. or R by R dash is equal to 25. So if the answer has, does the answer have 25? Yes, I think the answer has 25. Option D. If I'm not mistaken, it should be option D. So this is the correct answer. Okay, so the ratio of R by R dash is 25. So this is question number 1. Now we will do question number 2. The next question which we'll be doing is question number 3. So question number 3, let's read the question. So the question number 3 reads, an electric bulb is rated 220 volt and 100 watt. When it is operated on 110 voltage, the power consumed will be. So this question has got 2 parts. Now, if you read the first part of the question conveys us some information. What information does it convey us? We have an electric bulb. So we have an electric bulb, and this electric bulb is rated 220 volt. 220 volt is the potential difference. So remember, potential difference is given to you, and watt is given to you. That means what is given to you? Power is given to you, which is 100 watt. So this is the first information. After that, you have a full stop. So this is the information from the first part. So this is the first part. Okay, that's how you read the question. So the first part gives you this. Then the question goes to the second part, which is still, okay, we are still, okay, the machine, the system is still this one only, okay? The system is still here. We are still in the same system. Remember, we are not out of the system. But then though we are still in the same system, the question will be directed in some other direction. But remember, you are still in the same system, okay? So you are still here. So the first part will still be useful to you. So remember, this is what you should understand, that in such type of questions, the first part will help you find the second part, okay? What we are going to find now. So if we read the question, when it is operated on 110 volt, the power consumed will be. So now they are changing the condition, okay? Now they are changing the condition, but remember, we are still in the same system. So let them change the condition, but we are still in the same system, so we will proceed from here only. Understood? So whatever I just told you, let's see how we can use it in the practice and get the answer. For the second part of the question, they want us to find power. They want us to find power. Now see, in the first part of the question, power is already given to us. Okay, now they want us to find power for the second part of the question. Alright, now no worries, we will give them the power. We will find the power and give them. Okay, so let's do the question together. So let's try it in detail now. What will be which? So solution. We have read the question, and what we know is that there is an electric bulb. So draw an electric bulb, and then the electric bulb is rated at 220 volt. So the potential difference is given to you 220 volt, and the power is given to you, it's 100 watt. This is what you will write here. Given V is given to you 220 volt V, and then power is given to you, which is 100 watt. Now this is the first part, isn't it? This is the first part. This is the first part. So this is the first part. From these two values, okay, we'll have to find another value. We have to find the third value. So there will be a formula for these two. Okay, there will be a formula for these two. You just have to remember the formula and get the answer. So from these two, there will be a formula. So the formula is that of P is equal to V square by R. So we are going to use the formula of power. Okay, so after all, they want us to find power, so we are going to use the formula for power. So power has got the formula V square by R. So let's use this formula. So we have P is equal to V square by R. So what are we going to find here? It's very clear what you are going to find. You already have power, which is 100. You already have potential difference, which is 220, and we are going to find R. Okay, so we're going to find R. So power value is given to you, it's 100. Potential difference is 220 cos square, is it not? And you have divided by R. So let's just continue. 100, and this will be 220 into 220 divided by R. Go for cross multiplication, so you'll get R into 100, and you'll be getting 220 into 220. So R will be here, 220 into 220 divided by 100. 2 zeros gets cancelled. R value you'll get by multiplying 22 into 22. So if you multiply 22 into 22, what you will get? You'll get 484. So R is equal to 484 ohms. Finally, don't forget to write the unit. Okay, so you got R, 484. Now this, okay, this will be used, okay, in the second part of the question. So now we are going to the second part of the question. In the second part of the question, remember, the system is still same. Okay, we are still in the same system, but now, though we are in the same system, we are told to find something else. So we will find something else, but remember what you have just found, you should use it. So this will be used. This will be used. Or also, why did we take the trouble of finding this one? Is it not? We took the trouble of finding this one because this will be used further. Okay, so now we will be using this value. Okay, so for the second case, what you know, at least you know the resistance. Okay, for the second case, you know the resistance. So when it is operated on 110 voltage, so there are some information which are given. Okay, for the second case, which is potential difference is given to you. So potential difference is given to you. Okay, for the second case, okay, what do you know? You know potential difference, which is 110 volt. Okay, the power consumed will be, see, for the second case, the question has only provided you with potential difference. With just potential difference, now you tell me, will you be able to find anything? No, there is, okay, with just potential value, you will never be able to find the value of power. Okay, you will never be able to find power, because power formula, have a look at power formula. You want to find power. The formula of power is V square by R. So of course potential difference is here given to you, but don't you need R? Yes. Do we have R? Yes, we have R. This is our R. So that is why we were calculating R. Okay, so such type of question, remember, there will be two parts, part 1, part 2. From the part 1, okay, whatever value the question is provided you, from there get something. Okay, use the formula and find the missing quantity. This missing quantity is going to help you in the second part. So from the first part we found R, and this R is going to help me find power in the second part. So you know R is 484 ohms, and what we are supposed to find? Power. Now this is very easy. Okay, so we know P formula is V square by R. So P we are going to find, so just keep writing P. V square will be 110 K square, and this is R, which is 484. So P is equal to 110 into 110 divided by 484. So P is equal to, should we cut or should we multiply? So let's multiply, okay, or should we cut? So if we cut, this will be 2 to the 4, 2 4 the 8, 2 to the 4. This is 2 5 the 10, 2 5 the 10. So again, let's cut by 2. 2 1 the 2, 2 to the 4, 2 1 the 2. This will be 2 5 the 10, 2 5 the 10. This is 121, so 11, I know. This is 11 5 the 55. 11 into 11 is 121. Okay, then 11 1 the 11. 11 into 5 is 55. So after simplifying and cutting, what we get? We get 5 into 5. So power is equal to 25, and don't forget to write the unit of power, which is watt. So W. This is the answer. Okay, this is also an MCQ question. So the option has 25 watts as one of the answer. Tick that and you'll get the correct amount of marks. Okay, so this is question number 3. Now we will do the next question. The next question, what is the next question? Let me see. The next question will be question number 4. So we will do question number 4. Now question number 4. Let's try solving question number 4. So let's read the question first. The question reads, two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combinations will be. So what do we need to find here? We need to find the ratio of heat produced in series combination and parallel combination. So we need to find the ratio of what? Heat produced. Okay, so the question is quite lengthy. At one go you may not understand, so read the question twice, thrice, okay, 4 times, 5 times, as long as you don't understand, and try to get something out of the question. So if we read the question again, what we know is that we get to know that there are two conducting wires. Okay, so whatever you get it, okay, you just write it on the graph. So we know that we have two conducting wires. So let's say this is wire 1 and let's say this is wire 2. So we have two conducting wires of the same material. So the material is same. So the material is same. So they are made from the same material. Now this word material is a very important word, okay, which they have used in this numerical question. Now remember, in this chapter electricity, material, okay, this material is spoken, okay, with respect to the topic of resistivity. So whenever the word material is used, okay, I want you to immediately shift your attention to the topic of resistivity. Resistivity, okay, in resistivity, the topic material comes into the picture. This comes under the topic of resistance, where one of the factors on which resistance of a conductor depends is material. Okay, so the nature of the material. So definitely this comes under resistivity. Okay, so resistivity means again rho. So you will have to remember this again. So remember, in this chapter, if the word material is mentioned, means it's resistivity, and if it is resistivity, it is rho. All right, remember this. So the material of the two wires are same. So remember, they have the same material. If this is copper, then this is also copper. If this is aluminum, then this is also aluminum. Remember this. So let's give name to the two wires. Let's say wire A, wire B. Okay. So the material is same. That means resistivity is same. That means rho is same. And of equal length. Even the length is same. Did I make the length same? Okay. The length are also same. So length is also same. Okay. What things are same? The things which are same is we have the rho, which is same. Material is same, so rho is same. Okay. Then we have the length also, which is same. Okay. And of same length and equal diameter. So the diameter is also same. Now what is diameter? See, diameter, okay, diameter has to be drawn in circle. So same diameter means the diameter is, okay, like this. This is called diameter. Okay. From one end of the circle to the other end, this is called diameter. So this is diameter. So the diameter of the wire is also same. That means what? Thickness is same. Okay, thickness is same. You see this marker? Yes. Imagine this to be the wire. Okay. So right now, if I hold it like this, what you see is the length. Okay, you see the length. Now, if I want to show you the diameter, that means I have to make it face like this. So right now you are seeing the diameter. Okay, from here till here is the diameter, which is also known as cross section, which is also known as thickness. So right now you are looking at the thickness of the marker. If I do like this, you're looking at the length. If I do like this, you can see the thickness, also known as the cross section. Okay, so whenever diameter is being mentioned in this chapter, in the numericals from this chapter, remember it means cross section. And cross section means thickness. It means thickness. All right, so it means the area of the two wires are same. Okay, so that means area is same. So this question has got three things which are same. We have the resistivity, which is same, we have the length, which is same, and we have the area, okay, which is same. How did I conclude that the area is same? Because the diameter is same. Look at these two wires. I am showing you the front side. Area means this one, the space inside the circumference. Are they not same? It will be same. It will be same because the diameter is same. Okay, if the diameters were not same, it can be like this. Now I know you will disagree with me that these two have equal area, because look at the diameters. This diameter is small, this diameter is big, so how can they be equal? But here you will see that, okay, the diameters are same. If the diameters are same, means area is also same. Are we clear? All right, so these things are there, okay, which the question is mentioned. Then we are till here. Okay, now these two wires, wire A and B, are first connected in series, and then they are connected again in parallel in a circuit across the same potential difference. Okay, this we will do later when we draw the diagram. So the potential difference across which the two wires will be connected in series as well as in parallel will be same. Okay, then the ratio of heat produced in series and parallel combination will be. So finally we are supposed to find the heat. We are going to find heat. Now, my dear students, there is only one formula for heat. So that means, okay, this question is very direct. Eventually you are going to find heat, and there is only one formula for heat in the entire lesson. Which is that formula? The formula of heat is I square RT. So you will be needing this formula. All right, this formula will be needed, and we will be definitely using this formula. So let's start. Okay, now let us start. So make sure that you write these things in a rough, okay, because afterwards I will erase this. I'll try to finish this in this area, and then I don't know whether I'll be able to finish, but I'll try to make sure that the answer is finished in one slide. Okay, so given, always write given. Okay, this is important. Okay, it's appreciated, your teacher appreciates if you write this. So write given. We know we have these things we have to write. So what is given? Okay, so we know, we have already discussed, since rho, length and area is same, remember the resistance of the two wires are also same. All right, remember this. Since rho is same, since the material is same, since the length is also same, and the area of cross section also same, that means the thickness is also same, the resistance of both the wires are same. Understood? So since rho, L and diameter is same, so area is same, area are same, the resistance of the two wires will be same. So let us declare that. So let R be the resistance of both the wires. All right, so we are declaring that R is the resistance of both the wires. Now the question says that these two wires are connected in series and then in parallel. So let us see for series. So how will these two wires be connected in series? In series they will be connected like this. Wire number 1 and then wire number 2. Okay, when connected in series, when connected in series, and then here you write when connected in parallel. Alright, so this is in series, and in parallel they will be connected like this. It will be connected like this. So these are the resistances, and we have declared that the resistances will be R. We have said that R will be the resistances. Okay, so this is R, this is also R, this also R, this also R. So let us calculate the equivalent resistance for this combination. So let us find the equivalent resistance for this. Since the combination is in series, we will use the formula for series, which is Rs is equal to R1 plus R2, which is R1 is how much? R1 value is R only, and R2 value is also R only. So the equivalent resistance is R plus R to R. So this is the equivalent resistance for the series. Now let's calculate for parallel. So the formula is 1 by Rp is equal to 1 by R1 plus R2, 1 by Rp. Remember, my dear students, whenever you're doing a problem on parallel combination, don't forget, okay, always write this left hand side. Okay, keep on writing. Okay, keep on writing. I'll tell you when, okay, this when you will have to cross multiply, but keep on writing, keep on writing. Okay, I see that most of the students, they don't write this, they will not write this, and they will just write equal to, and then they will continue solving. That is wrong. You have to write the left hand side also, because at the end, okay, after everything has been simplified here, you have to do cross multiplication. So do not, okay, do not omit this. Okay, do not omit this. Keep writing, keep writing, keep writing. At one point this has to be cross multiplied. So R1 plus R2, okay, put the values of R1 and R2. So 1 by R plus 1 by R, because both R1 and R2 values are R only. Okay, so can I write? Yes, I can still write. So 1 by Rp is equal to R plus R. LCM of R and R is R only, so you'll get R into 1 is R, 1 into 1, 1, so you'll get this. Okay, now, so I won't be able to finish the answer in this space, so I'll have to erase again. So make sure that you are copying this, okay, because very soon I'm going to erase this. Unfortunately, I won't be able to finish this here. So 1 by Rp is equal to 1 plus 1. 1 plus 1 will give you 2, and you have got R. This is where, okay, this is where cross multiplication will take place. So now you will do cross multiplication. Okay, this X you show in pencil. Okay, don't show this in pen. Okay, this I am showing you. Okay, who multiplies with whom. So just to tell you the direction, who gets to multiply with whom. Rp will get to multiply with 2, so you'll get Rp into 2, and R will multiply with 1. Anything multiplied to 1 is the value itself, so R only. So you get Rp here, and then R will be there. This 2 goes below R. So this is the, okay, equivalent resistance when both the wires are connected in parallel. So for series you have this one, and for parallel you have this one. Alright, so I hope you have written this down. I'm going to erase this. Okay, I'm going to erase this. So let me erase this and continue. So write down till this much, and then I will erase this now. Now, next what we are going to do, now it's mentioned in the question that, where is it? Yes, it's mentioned in the question that, okay, they are connected across the same potential difference. So the potential difference is same. Okay, so write down here, since since voltage applied in both the cases is same, let V be the potential difference comma and time taken be T. Now potential difference, okay, across the 2 points is same. It's written here, okay, across the same potential difference. Since the potential difference is same for both, we will use the potential difference to be V, okay, and the time taken we will say is T, okay. So time taken be T. Now we are going to use a formula here, okay. We are going to bring a formula of heat. So now we'll calculate heat. So then heat generated, because this question is asking heat only, so we'll have to deal with heat. Then heat generated is given by the formula of heat is H is equal to I square R T. This is the formula of heat. So this is the formula of heat. Now let's calculate the heat. So H is equal to, see, I square. Resistance we have, okay. For this question the resistance is R. Time will be T. We have just declared that time will be T. Now we don't have I square. There has been no mention of current throughout the question. So what we will do is we will have to substitute this. So we'll have to substitute this. But how will we substitute this? We will substitute this using Ohm's law. So using Ohm's law, what you will do? So using Ohm's law is V is equal to IR. So let's make a formula for I to substitute I. So I will be V by R. Yes or no? So now instead of writing I, we will write V by R. So I square will be V by R square, R and T. Alright. So this is H is equal to, this is V square and this is R square into R into T. This R and this power will get cancelled. So H is equal to, you are getting V square by R into T, or just write V square T. So this is H, okay. This is H. This is heat, okay. This is the heat that we got. Now we will use this, okay, separately for series combination, and we will use this formula separately on parallel combination, because here the wires are combined in series and in parallel. So we'll apply this formula in both the cases, okay. So let's do here. So this is the series one and this will be the parallel one. So what we have so far is, so HS, okay, heat in terms of series. So heat in terms of series, it will be V square. Let's first write down the formula once. R H is equal to, everything will remain same, upside will be same. R value, what value of R did we get for series? Go and check and tell me what value of R we got. I want you to tell me the answer of this one. R is equal to, what value we got? We got 2R, na? Because R plus R was 2R. So this is RS, okay. We have to put the value of RS, which is 2R. So here we put here 2R. Okay, nothing to cut. So this will be the answer for this question. No, this will be the answer. This will end it here. So HS we're getting this. We don't have to cut. We're not going to cut. Nothing to cut here. Next, for parallel, let's go for parallel. For parallel HP, okay, formula will still be same. V square T by RP. Now you let me know the formula of resistance in parallel. What did we get? What value of RP did we get? Did we not get RP? What value of RP did we get? did we not get Rp to be, how much did we get Rp? Rp to be R by 2. Yes, I think we got Rp to be R by 2. Yes, so we got Rp to be R by 2. So let's substitute the value of Rp with R by 2. So V square T, and this is the main division, and you have your fractional division R by 2. Okay, so let's take care of this one. So if I take care of this one, these two will go up and R will remain down only. So HP, okay, this will be V square T R, no sorry, 2 into 2 by R. This is the value of HP. So this is the value of heat in parallel combination, and this is the value of heat in series combination. Now we are at the final point, which is we have to find the ratio of this only. Find the ratio of heat produced in series and heat produced in parallel. So let's get the ratio of these two only, okay? So let's get the ratio. So let's get the ratio. So we have to divide this value by this value. So let's divide this. So HS divided by HP. So HS value is V square T by 2R. Remember, this is the main division, and we have V square T into 2 by R. So next it will be V square T by 2R. This will become into, then R will go up, and then V square T into 2. Let's start cutting now. V square cut, okay, and then this is 2R now. Yes, R cut, T cut. What is left? You're left with upside nothing, 1, and downside you're left with 2 into 2. 2 into 2. So HS by HP, you're getting 1 by 4. That means HS is to HP is equal to 1:4. This is the answer, and this must be the answer in one of the option. I think it's the option C. Is it option C? I think it's option C, yes. So this is option C. So this is it. Okay, this is question number 4. So with this I'll end this video, and then in the next we will continue with further question. So I'll see you again in the next video.